All right, so let's get started here. Welcome to another exciting learning lab. I'm really pumped for this one. And why? Because I spent the past 3 weeks working on this new technology called Modeltime nested forecasting. It's amazing. You guys are going to see so much cool stuff today. And I'm just, really excited to get this thing kick-started. So we'll get going here. The agenda for today, there's 5 things we're going to cover. So first is going to be a business problem, and that's going to be something that's common to almost every different industry. It's working with sales data. Next, I'm going to go through immediately. I'm going to give you 3 pro tips, and these are my personal tips on how to scale forecasting. So definitely we're going to hit the ground running. The third thing is I'm going to show you Modeltime innovation. So what have I been working on the past 3 weeks? Integrating into my Modeltime software. This is something that's really cool, nested forecasting, and we're going to learn all about what that means here in a few minutes. Then what we're going to do is go through a full code tutorial, and I mean full code. So this is line by line. We're going to go through about 225, 230 lines of code, and it's going to be a lot, but it's going to show you my entire process for doing forecasting at scale, using this process of nested forecasting. And then at the end, what we're going to do is we're going to recap, and we're going to go through a special offer. For those of you that stick around to the end, you're going to get some special offers on my courses, and it's going to get you kicked off on your journey for learning time series. So I'm excited for this. Here's the general process that we're going to be going through. Well, I forgot to include the picture here, but a general workflow that we're going to be going through today is 3 stages. We're going to do an assessment phase, which is where we just take one time series. So think of it like one of these little pieces in here. We're going to analyze that. And then what we're going to do is we're going to show you how to then scale that up to a lot. We're going to do 100 of these time series. And then what we're going to do is once we have that analysis packaged up, like I do in most of my trainings, I want to give you guys an example of what you can do with this in production. So that's where we go to our 3rd stage, which is our Shiny app. And that's where we share our content and we put it out there in the world so the world can see it and be able to interact with our data science. Now, this is normally your world is in a company where you need to give sales forecasts to either leadership or marketing or sales departments so they can do their thing and be able to make good decisions from this. So that's what we're going to end with is a Shiny app. This is part of our Learning Labs project. And this is something that I started 2 years ago where we have already over 60 labs. This is lab 63. And it's something really cool where we go through and do these like bite-sized courses. They usually take about an hour to an hour and a half. And we just keep adding to the list. So we have a special time series forecasting with Modeltime section in our Learning Labs Pro membership service. It is a paid service, but you get access to all of our labs, anything that we've done in the past. So all of the code, the Shiny apps, and everything. We have a special section here called the time series forecasting, and we're going to add lab 63 right in here. I'm going to put a link to Learning Labs Pro for any of those that want to check it out in the chat. So I just put that into the chat. So check down below in your chat window and you'll see it pop up. The cool thing about Learning Labs is we touch all of these different topics that are outside of my core R-Track curriculum. So I actually designed this program for kind of your somebody who's already kind of past the beginner stage, but who's ready to take on some of these really cool projects like the one that we're going to show today. So there's 50 plus labs. There's actually 60 plus labs. These are 1-hour courses, and they have hundreds of valuable bonuses. So let me talk about the bonuses real quick. Normally what I do is I create a Shiny app or a Dash app for the Python courses. And we've started to amass quite a few of these Shiny apps. And these are apps that probably you could, if you were a consultant, you could sell these for a couple $1,000s a piece. I give them away as part of this Learning Labs Pro membership program. So you get apps like this, where we've got a Shiny customer retention app. You've got Shiny hierarchical forecasting app. You've got a loan default score, the Shiny NLP token automation app, Shiny customer segmentation app. And these are just a handful of the ones that I've done over the past, 5 or 10 labs or so. The bonus today we're going to be making this nested forecasting app. So you can see the forecaster right here. It's powered by my Modeltime R package, and it's really cool. I'll explain all about how it solves our problem today once we get to the business problem, but this is going to be the bonus today. So definitely check that out. All right, let's hit the ground running. I want to talk about the business problem. So we've got product sales that we're going to be estimating or forecasting, and we're going to be doing this for a little company. You may have heard of them. They're called Walmart. So, and the data set that we're actually using, it comes from the M5 forecasting competition. I've adjusted it a little bit to aggregate it up so that we're going to be analyzing all of the product data for them. So Walmart has many products, as many companies do. And what they want to do is they want to be able to forecast those products. So you can think of Walmart, a massive, giant store that is globally operated, and they have thousands and thousands of products that they need to be able to have, forecasting done for, so they can estimate what the demand is going to be and when they need to purchase certain things. So this data comes up from the M5 competition. The problem that we're trying to address today is that there's so many products to forecast. And this is a common problem. I get this from my students all of the time, where one of the big questions is, how do I scale up my forecasting? I'm learning from my time series course that, how to do all this, how to do the model experimentation phase and everything. But I want to scale my data up. So I go through that in my course for global models. We'll talk about that in a minute, but we're going to talk about a second strategy today. And this is actually the more common strategy that most companies are implementing, is iterative forecasting. So we have now integrated that into Modeltime. I'm going to show you the solution, an example of what I'm talking about that we're going to be doing today is giving our organization scaled time series results. So this app that I'm going to show you right now, this is the bonus that I'm giving away to all of my LL Pro members. And what's cool is they can pick all sorts of different products in here, and we can just add a couple of these products in here, click the apply button, and this app is going to update, and it's going to produce the forecast for all of these. So if I hit the apply button, actually, I'm not sure why that didn't run. Let me reset it. And this app is actually based on the one that I teach in my 5-course R track. It's based on the Shiny App project here. So you can see we've got all of these different forecasts in here. Oops, I clicked the reset button. It's going to reset on me. So it just reset to the default. And here, let me try that one more time. Okay, let's refresh this. Sorry, I think I tried to do too much at once. So this app, though, it's pretty cool. It's got all sorts of different functionality to it, and it's actually running R behind the scenes. So I'm just going to click the, wait a second for it to pop up. There it goes. Okay, so this is how the app starts out. We've got 3 different products in here, and we've got the forecast for them. So what we're going to do next is we're going to add an additional product. I'm just going to do one product here at first. And if I hit the apply button, it's going to update. And what we'll do is we'll get the 4th forecast in here. Okay, and what it has is you can see what the forecast should be. And it's got 3 different models in here. This first model is a temporal hierarchical model that's being used. That was the best model that performed best on the test forecast. So we did a test forecast, a 90-day window, and we can see that the test forecast on this Foods 3090, this one did the best. This was the forecast that was selected. It was from this model here. And we've got the same type of situation. We've got an XGBoost model that was selected here, a different XGBoost model, and a different XGBoost model. So I'm going to show you how we did this for 100 time series today. And you've got the test accuracy for each of the different models. And you can see that this first one, Foods 390, this one had the lowest, and I think the measurement was RMSE that we selected, and we picked the best model there. And that's what we used to forecast. We'd have the same thing for Foods 589. The best one was this one right here, this XGBoost 2. So that's how these models get selected, and that's how we're making our forecasts. Okay, so that's the app in a nutshell. That's what we're going to be building today. And it's really cool. It's a lot of fun. And it's also very important for your businesses, because imagine yourself if you're able to produce these shiny apps and deploy those in your company. That's going to give you, that's going to make you really valuable. And that's going to give them a lot of help in the areas where they need to be able to make data-driven decisions. So I'm going to give you 3 tips that we're going to talk about when dealing with large-scale forecasting problems. So the problem again today is we've got Walmart, who has lots of different products. Now we're just going to be analyzing 100, but you can think of they might have 1,000 or 10,000, and that we need to be able to do this scalable forecasting for. So my first pro tip today: start with one time series. And I know this sounds simple, but I see this time and time again where data scientists, when they're just starting out, they try and do everything at once. They try and create all of these different models and scale it up to a 10,000 time series. And I'll tell you this from my own personal experience. I know the first time I tried to do scalable time series forecasting, I did the same thing that I'm telling you not to do. I tried to scale it up, and I got to about the 50th time series. And you know what happened? My models, my loop that I had written failed. I had an error and I lost everything. So I spent, a couple hours doing all the coding and everything. And then, an hour or so running this analysis. And it was very time intense. I didn't have parallel processing like we have today. And, I lost everything. I was very frustrated. So my first pro tip is start with one time series. So make it easy. Hit that easy button. Don't try and, do everything at once. So forecasting a lot of time series is hard. Just try and simplify your problem when you're starting out. That's my number one pro tip for doing this type of scalable forecasting. My second tip, okay, so we know to start off easy. Now we need to scale efficiently. And what I mean is we need to have a way, because one of our strategies is to use a lot of different models and test them out. So you notice that in this app, when I'm making a forecast, I'm testing all 3 of these on this particular time series, and then I'm selecting the best forecast, the best model that did the best on the test set. So that's what we want to do. We want to scale that. And that's a lot, because we have on one hand many models, and we have on the other hand we have many time series. So we've got to apply 3 different models or 10 different models to every single time series. And if you have 100 time series, that's 300 different models that you got to train. So the thing that you want to be very mindful of is use your time wisely. It's your most precious resource. Okay. So the strategy is that we want to test out many models. We don't want to go in with a preconceived notion that, hey, this model is going to win out all the times, because it's not. And we're going to see that today. But this type of experimentation, which is what I call, when you're measuring with many models and you're training all of these different models, that hurts our time. It increases accuracy, which is why we do it, but it hurts us in our time. So we want to be efficient. So that's why we want to implement something like parallel processing. So if you have, say, 6 cores on your computer, that means you can spread your computations out across each 6 of those core and run them all in parallel. So that way it saves you potentially 6x faster time. And we're going to see that today. So that's my second pro tip. Scale efficiently. Make sure that you do parallel processing. My third pro tip is anticipate errors. Expect that something is going to go wrong. And I'll tell you this, I used to have a manager when I was probably like 10 years ago now. And he always used to tell me this. He used to say, people don't plan to fail. They fail to plan. And this couldn't be more true. That was one of the quotes from him I took away, and I took that to heart, because, he knew that, no matter what we were doing, we were always going to run into some sort of errors. And it's figuring out how to deal with those errors and figuring out how to really be able to kind of get through those issues in the edge cases. So we need to have a plan when something goes wrong. And what we want to do is we want to implement some sort of methodology. So what I do, and we're going to talk about this, is we want to implement error tracking. And this is where we take some sort of analysis, we see which models have failed, and then we kind of put those into a different bucket and we analyze those separately. I call those edge cases. So anticipate that you're going to have errors, set up your parallel processing so it just keeps track of those errors when they happen, but it doesn't fail. So that way it keeps going through all of the different, all of the time series. And that's how we're going to achieve scale. So those are my 3 pro tips. Now, what I want to talk about is my model time nested. So what have I been working on the past 3 weeks that has me so excited today? Well, I've been working on solving each of these 3 pro tips and these problems that we have commonly and adding functionality to model time to allow us to do them. So let's talk about that. The main idea here is that businesses are shifting and they're making a change out there. So organizations are going from having to analyze just a few time series to thousands and thousands of time series. So this is no different than Walmart than it is at your own business, where they may have fewer products, but they still have hundreds and hundreds of products. So this is what we call time series at scale. We need to be able to automate this process. So how do we do that? Well, one way that we're going to talk about today is called iterative forecasting, being able to produce each one of these kind of analyses, these forecasts on each of our different time series, one after another. And we need to do this, thousands and thousands of times. So what we're going to do is we're going to implement something called Modeltime, which is an R package and actually an R ecosystem of packages, because there's several packages that as this growing ecosystem keeps increasing in size. But the main idea here is that there's tools out there that can help you in this process. So what Modeltime is, you can see here, we're going to be focusing on this big one here at the top, but there's also an ensemble, a back testing library, a deep learning library, and now an H2O auto ML library. It's an R package that I developed for forecasting. The reason I developed it is because I was actually trying to develop the time series course that I launched last November. And it was very challenging with the existing tools to try and implement the most cutting edge algorithms, the things that actually people were getting success with. So what I did was I then kind of stopped what I was doing as I was building that course. And what I did was I started reviewing all these different time series competitions where they were having to deal with scale. And I was looking at the M5 competition from Kaggle. I was looking at several other competitions, I think 3 other different competitions, several of them were on Kaggle. And I found out that all of these competitions, they were implementing kind of a machine learning approach where they were doing time series at scale, lots and lots of time series, same type of problem that we have right now. And they were each coming through different solutions. So I started developing this ecosystem. What I wanted to do was I wanted to integrate tidy models, which is, if you're familiar with R, tidy models is a machine learning library that is similar to Python's scikit-learn. It's actually, in my opinion, very easy to use, probably a little bit even easier than scikit-learn. And what Modeltime does is it integrates all the time series models. So ARIMA, Profit, it even has exponential smoothing, all the different time series models, and it integrates the tidy models. So things like XGBoost, like GBM, all of the different machine learning libraries, it now has those in one system that is designed for forecasting. And it's easy to use. So we're getting a lot of good results. I'm seeing a lot of my students have a lot of success with it too. And then there's other packages that I've developed. I'm not going to talk too much about these today just because they aren't as applicable to this problem, but they are very powerful. And I teach these in my time series course. Back testing, ensembling, deep learning, H2O, and these are all built off of the winning competitions where they were using things like deep learning or things like scalable machine learning and applying lots of different models. So we have H2O AutoML. A lot of them integrated ensembling to get that winning solution. And then they most often did some sort of back testing. So we've got these solutions developed. So it's pretty cool. I've been putting a lot of time developing it over the past 2 years. All right, so we're talking about scale today. Modeltime is developed with scale in mind. That's when I set out to develop Modeltime. This was the problem that I saw organizations are facing, and this is the solution that I wanted to develop. So there's 2 different methods to scale. The first one is global modeling, and this is about 100x faster than what we're going to be doing today. Now, with that speed, it becomes a little bit less accurate, but it can often be a very good solution if you have 5,000, 10,000, 100,000 time series that you need to model. You can build several global models and then pick the model that works best for the individual time series. That way you're only dealing with like 6 or 10 models versus 600 or 600,000 models. And that's what global modeling is. We're not going to talk about that today, but I will talk about the time series course at the end, and I teach global modeling in there. What we're going to be focusing on is what's called iterative forecasting using a new approach that I developed called nested modeling. It's slower, but it's more accurate than this global modeling approach. And it's what people typically do when they think of like iterative forecasting. It's taking each time series, maybe training an ARIMA model. If you have 1,000 time series, you're going to make 1,000 ARIMA models. And that's what we're going to be trying to do today. Not necessarily with ARIMA. We're going to be using XGBoost, and we're going to be using a new algorithm that I will talk about once we get to the code. So speaking of the code, let's talk about it. So the nested forecasting solution that we're going to be implementing today is a combination of two different ideas, right? You've got a nested data frame. I'll talk about what that means once we get to the code. But that nested structure is going to store many time series and many models. And then what we're going to be able to do is produce those forecasts. It's an iterative analysis approach. It's built for scale, parallel processing. It handles errors gracefully, which is very important. And it's going to use a key concept called logging in order to be able to do that. It's extremely easy to run. So I've designed it. If you want to implement parallel processing, you just do parallel start, and then you make sure in your control, you do allow parallel and set that equal to true. And all of these functions that we'll see today have the ability now to run in parallel. The nice thing about this, though, is that situation I was talking about at the beginning, when I got through 50 time series and then it failed and I lost an hour's worth of work. You're not going to have to worry about that with Modeltime, because I've designed it to do logging and error handling. So it pushes everything that you need to the most expensive operation, which is going to be the training phase. And then that training phase proceeds even when an error occurs. So why do I do this? Well, the first benefit is that you can retrieve key information instantly. So when I log stuff, then you can pull that log. You don't have to like try and predict something or find the model that you want to use to make the prediction. It just has everything stored for you. The second thing is, and benefit number two, we can check the error logs and isolate edge cases, and we can handle those edge cases separately. So we're going to follow this exact same path in this code demo today. All right. Oh, I saw a question here. Is this package available in Python? It's not. So if you're familiar with the Python ecosystem, there's no parallel to Modeltime. There's nothing that does the either panel data the way that we handle, or the iterative approach here. SK-Time is probably one of the more popular time series libraries, but you're kind of up to your own to implement this kind of iterative approach. Okay, so yeah, but don't feel bad. Just means that you can try out R. R won't bite. Okay, so we're going to go through the code, and we're going to check out what I've got in store for you today. So for my LO Pro members, this is what the project looks like. So when you get that download for Lab 63, you're going to open up the zip file, unzip it, and it's going to have all of this stuff in here. So the primary file that we're going to be working out of is o1analysis.r. We also have the forecast app.rmd file. That's actually what's running behind the scenes here. And that's producing this file right here. And what that's producing is this app over here. This is our bonus. And then beyond that, so I'm actually going to stop this app. What we have is a few folders here. Artifacts, these are things that I'm going to store as my analysis progresses. You can see the file sizes are pretty big. So I may not provide these to the LL Pro members, just because I don't want to bog you down and cause you to take forever for you to download these. But we'll see. We're just going to be producing those as our code progresses today. The data set, so that's these Walmart item sales.rds file. So we're going to be using that. What it is it's like 102 different time series for aggregated product data. from Walmart. So different items, it's all items, and it's all the sales that Walmart had for those items over a certain period. In the scripts, this is the make data. We aren't going to use that today, so we can safely ignore that. We're primarily going to be working out of this file, and then this is the app. So the analysis file that we're going to go through today, and I'm going to make sure I start a fresh session. So I'm just going to restart my R session by going to my environment. Oops. It does that. Sometimes it'll fail if you have parallel processing running and you forget to shut it down. So let me do this, get back in here, make sure we've got a fresh session going. And here we go. There we are, we're back. Okay, so we're in the O1 analysis. I'm going to open up my environment. My environment's empty, and we'll just kind of progress down through our analysis. We're going to be showcasing iteration, parallel processing, and error handling. As you can see here, I have my outline open. So to follow along, the keys, the things that you want to watch out for in this outline: bonus number 1, we're going to talk about a new algorithm. Bonus number 2, we're going to showcase a new workflow at the end. And bonus number 3, you already saw this, but it's going to be the shiny app. So we've got 3 different bonuses we're giving away just in this lesson, in addition to the main topic, which is iterative forecasting. All right, let's get started. I'm going to run through and load up the 4 different libraries that we have here. So I've got Modeltime, Tidy Models, and is it loading? Tidyverse? There we go. Yeah, sometimes it takes a little bit to run. Okay, there we go. We're going to load in our sales data. So our sales raw table looks something like this, where we have 193,000 rows by 3 columns. So we've got the item ID. This is our grouping variable. So each of our time series, foods 3090, is just one product item that Walmart has. This particular day, they sold 1,046 units. And this is the timestamp that occurred on. And then you can see it kind of progresses. So we've got a lot of data, and that's because this time series extends probably like 5 years or so for each of these timestamps. The next thing is I'm just going to take a sample of 12 items, and that's what this does here. So I'm going to filter, because this is a factor, I can convert it to a number, and I can just check out. We can do like the first, say, 12 of these timestamps. When I filter that now, we just have 12 time series, 22,000 data points, and we can do a group by and plot time series. And what this is going to do is it's going to pull up a plotly plot of my time series. And I normally start out my analysis this way, where I want to investigate and just see what these time series look like. So I grouped by the grouping variable, this item ID, and you can see that this is what it looks like. The sales data has kind of some spottiness to it. You can see some days it's 0. If I zoom in, I can see that there's these periods where there's what we call intermittent demand, and then the demand will spike back up. Sometimes this happens, at some sort of seasonality, but other times it's just kind of random how this happens. Some of it has the seasonality, so you got kind of this wavy pattern. This one has a strong seasonality to it, a nice wavy pattern. This one looks like it had a dip down in here. So this is the type of data that we're going to be dealing with, and we have over 100 of these time series. So we've got to be able to automate this process. The next thing I'm going to do is I'm going to talk about the data structure that we need to get this data into in order to perform nested forecasting. So we're going to be doing this iterative approach where we apply 3 different models to this first time series, 3 different models to the second one, 3 to the third. And what it's going to do is it's going to produce a forecast for each one of these. And then what we're going to do is we're going to pick from each one of those forecasts, which one we're going to decide which model had the best. And we're going to store that information for each different time series. And we're going to use that information in order to refit, so retrain on the full data set, and then forecast forward. So to get that into the nested structure, what we need to do is we need to take our sales data, and we need to first group by the item ID. And what this does is it makes 102 different groups by the items. Then what we're going to do is we're going to extend the time series. So each of this time series, we're going to extend into the future a certain number of periods. Now, my business objective for this, which I haven't talked yet, is to forecast the next 90 days. So normally you'll have kind of an idea of what your business wants to forecast. If they're forecasting for the next quarter or so, your forecast would be 90 days. If they're forecasting for the next year, it would be 365 days and so on. So we're going to extend each of the time series by the item ID, which is our ID variable. And we're going to tell it that it has this date variable. We're going to extend each of them 90 days into the future. So that's what this piece does. Control Enter. And we're going to see that it goes from 193,000 to 202,000 rows now. And then what we're going to do is we're going to convert it to a nested structure. Now, we're going to split out the future data. So now there's 202,000. And all it did was it filled in future timestamps with a missing value. So the value will be missing. So what this nest time series is going to do is it's going to take that future data and split it up into a nested format. So let me run this. And while that's running, I'll explain what's going on. It's going to convert these values into actual data and future data. So now we can see what it returns is 102 rows, where each of these rows has a unique identifier. And in each of these columns, we have what's called a nested data frame. So nested forecasting, that's where it gets its name. It has a nested data frame where it has 1900 by 2. So that's going to be basically the value and the date column is going to be stored inside of this cell inside of the data frame. The same thing that happened with the future data that we just built, which is just new timestamps with missing data that we're going to fill in when we do our future forecast. It's created 90 by 2. So, and then what we're going to do, the last step here is split the nested time series. It's going to take our actual data and we're going to create training and testing splits off of that. So let's run this, Control Enter. And what it'll do is it'll create the nested structure that we need to be able to do our nested model time forecasting. And there it's done. We've got our nested data. We can see that there's a split here and we've got 1823. So of this 1900, 1823 is going to go into our training data and 90 is going to go into our evaluation or our testing data. So this is what we're going to run on. Okay. The next thing that we're going to do, we're going to go through modeling, and this is going to be the fun part. So everyone loves modeling, including myself. It's the exciting part. We're going to go through and show you how to do the modeling now. So now that we have this nested data structure, we need to extract one of these. So I'm going to extract the training split from my nested data table. And what this is going to do is it's going to extract the training data. And this is the thing that we're going to want to build our features off of. We don't want to use the testing data because then we may have information leakage, and which is not a good idea when you get into machine learning. So we're going to first create a recipe for XGBoost. And what this is going to do is it's going to take this data set and convert it into something that XGBoost can analyze. So XGBoost, what we can do is we can build out some features related to the date, like we call these calendar features. So that's what the step time series signature does. We'll remove the date feature because XGBoost doesn't know how to handle date data. But when we build features that are ones and zeros off of this date data, it knows how to handle that. So that's what we're going to be doing. We're going to remove any predictors that have zero variance, which means they just don't vary. That's just a constant value because XGBoost doesn't need those, doesn't want them. And then we're going to dummy any of the predictors that are character data. So it's pretty straightforward here. And what we can do is we can just take a quick look to see what the before and after is. So if I take my recipe and I bake the recipe XGBoost using our data set here, which is this piece here. I forgot to prep it. So if I just run prep here, what prep does is it just kind of performs pre-calculations on a recipe. And you can see that now we've got a data set that looks like this, where we've got value as a function of date index numeric, date year, date ISO, date half, date quarter, date month, and so on. And you can see that it's much wider now. It's 40 columns. Okay. So the key idea here is we just turned that data set, which was just 2 columns, now into a 40 column, and we got rid of the date feature. So all of these features are either numeric. They shouldn't be all numeric now. And that's so it's either integer or double data. Okay, cool. Next thing what we'll do is we'll create a workflow. So what a workflow does is it combines both a model and a recipe. So the recipe that we're going to combine is this recipe XGBoost. And that's going to be combined with a boost tree with a learn rate of 0.35. And that's going to be my first XGBoost workflow. So I run this. And what this does is it creates a workflow. It's basically an untrained, it hasn't been trained on the data yet, but it's the instructions on how we're going to train it. You can see here, this is the workflow. It contains both a preprocessor and a model. The preprocessor has 4 steps here, step time series, and so on. And then the model has the boosted tree model from the tidy model with a learn rate of 0.35. Okay, cool. We're going to do the same thing for the second model. Now, the only difference between the first and the second model here is I'm just adjusting this learn rate. So XGBoost models are highly dependent on the learn rate. So I want to try a different learning rate out just to see if one performs better than the other. Okay, and now we get to our first bonus. We're also going to include a third algorithm. And this is a new algorithm. It's called temporal hierarchical forecasting, or THIEF for short. It was developed by, I believe, Rob Hinman and company, and it implements some really cool features to be able to develop basically a hierarchical model using different time series aggregations. So what it'll do is it'll aggregate your time series and then kind of ensemble the forecast. I also want to call out Alberto Almunia. He's a student in my time series forecasting course and also Business Science University student. And he actually created the implementation, which connected it up with Modeltime. So we're going to check it out today. So here's how we're going to do it. We're going to create a workflow. We're going to add the temporal hierarchical model here. And then we're going to give it just a basic recipe, which is not going to have any steps, but it just basically shows how to create the predictor. It's value as a function of dot, which will be value as a function of date. It's pretty simple model here that we're going to create. And we're just going to leave everything as the defaults and let Thief kind of figure things out. Okay. So now we're going to get to where we're actually going to start to do some modeling. Now, this is where most data scientists make mistakes. They try and just jump right into doing the full kind of analysis on all of their time series, and then they wonder why nothing works, and it costs them a lot of time. So what we're going to do is we're going to try out one time series, and this should tell us one thing. This is really important to understand, is it should tell us whether or not our models work for at least one of the time series in our data. So we'll just take the first time series and we're going to run this nested fitting process on it. So basically this nested data table, remember it's 100 different rows that contains a nested structure of our data sets. And what we're going to do is we're going to run it on our split, and it's going to basically do a calculation and come up with a training and a test evaluation. So it's going to train it on these 1823 and it's going to test on the 90. But we're just going to do it for the first one. So I'm doing slice 1, and you can see it's just a tibble 1x4 with our data in here. And then I'm going to run the first function that you need to be aware of today, which is called Modeltime nested fit. What this is going to do is it's going to fit our models, which I've included a list of models in here, and it's going to fit all 3 of these models to the training and test and forecast on the testing. So let's run this. We're going to see that it's starting. I have it set to verbose equals true. So you can see it's spitting out some information here, and it should be finishing up here right directly. And it took about 10 seconds to go through that first one. So if you do, multiplication, 10 times 102, if we do this in series, we're looking at, about 1,000 seconds, which is, not something I want to, have you guys wait for. So we do this because we want to check out what I'm looking for are these green checks here. I want to see that models are passing. If all of my models pass, then I know that I don't have any issues with my recipes that I've created up here, and I don't have any issues. I can, at least get a kind of a good feeling that we're ready to keep proceeding. So how I did that, I set verbose equal to true, so it spits out all this information. And then I saved it as this try sample tibble. And it's just and you can see what it did is it added the model time table, and there's 3 rows in this model time table, one for each of our different models. So we have 3 different models that we tried, 2 XG boost, and then the thief model. And then the next thing that you'll want to do is you'll look here, model error 0. That's a good sign. That's what we want to see. And then we can also, if we did have any errors, we could then use this extract nested error report, and it'll report the errors for us, but there weren't any errors. So we're just getting a table of 0 by 4. Don't worry though. We will see some errors here. I promise you that. We're going to get an error here in a minute. Okay. So this is a long running script. What I originally was going to do is I was going to, have you guys watch me forecast 102 time series, but then I realized waiting for 2 minutes while something is completing is rather dull, and I don't want to put you through that. So what I'm going to do is I'm going to show you just kind of the basic setup, but I'm going to add this line in here. If for my LL Pro members, when you guys go to run this yourself, what you'll do is you'll just comment out this line here. What this is going to do is I'm going to slice tail the last 6. And the reason I'm slicing the tail, so it's going to give me the last 6 of these, the last 6. And I know the last one, the 102nd one, there's an error that we're going to get. So that's why I'm doing slice tail N6, because I want you to see what happens when we get an error. So I'm going to first do parallel start. What this is going to do is it's going to fire up behind the scenes 6 clusters. Now, what I want to do is I want to go to my activity monitor, pull this up here. Okay, so this is my activity monitor, and it actually does look like, so when I did that parallel 6, all 6 of these jumped up for a second because my 6 cores are being initialized. And what I'm going to do is I'm going to run this just on the last 6. So let me run this. It's going to fire up the parallel backend on 6 clusters, and it's beginning that loop. Now it'll take a second to run because it's got to, for each one of these, it's got to parse the data out to the 6 clusters, and then it's got to run each of these models on each of those 6 different clusters. But it should happen pretty quickly that we should start getting some results. So you can think for 6 different time series. Okay, it took about 25 seconds. The other thing is I have a lot of overhead right now because I have Zoom running. I have all of this other stuff running. But you see that each of these jumped up and then went back down. What I see here is we've finished in 25 seconds, but we got a warning message. Some models had errors during fitting. So next, what I'm going to look at is the model time table, and I see model errors. 3 models had errors. So I want to know what happened. And that's what I'm going to investigate here in a second. So before I move on, though, I am going to load in all 100. So this took me about 2 minutes to run without having Zoom and everything. With Zoom, it'll probably take like 4 or 5 minutes running. So what I'm doing is I'm pulling in the nested model time tibble, and it's just like this 6 by 5, but it's got 102 by 5. So 102 by 5. So I've got all of my data in here now. Now I'm going to review any errors. That's the next step. So I want to check out my nested model time report. And this is what model time does for us. One of the advantages is we don't have to have the separate code to track any of the errors. It's already built in. So in this extract nested error report, we just run that function. And the thing I can see here, so these error descriptions are pretty cryptic, and that's just because we're just tracking whatever error message that are displays by default. Sometimes you can get some good information in here, but it's kind of tough to tell. But what I'm seeing here is that the item ID is all the same. So that tells me is all three models failed on this particular item, which means that we need to take a look at that item, and there might be an issue with the data. So what I'm going to do is I'll do that here in a second. Other things that you want to do at this stage, we want to review the test accuracy. So another thing that I might be thinking is, okay, in addition to errors, we might want to check out and see where our accuracies are really high, either on like a MACE or an RMSE basis. And what this is good for is to indicate, hey, special time series, we might need to take, if there's a lot of, if we aren't getting good results on some of these time series, we might need to get better models. So that's what I'm looking at here. I'm also looking at, if we get the dreaded null, that's the household 2 101. So that's all three of these models failed on that one. And then you'll, at this point, you want to visualize too your test forecast. Now, I'm specifically focusing on foods 3090 because this is the one that I had the worst RMSE on. And I just want to check it out and see what's going on. And I can see here that two of these models, the XG Boost, and here, let me move this out of the way. The XG Boost and the temporal hierarchical forecasting model, that one actually did all right. You can see here's the temporal. It did pretty good here. But the XG Boost models did not do so good. You can see it had this dip here. It probably saw another dip in here and kind of expected that. So we wouldn't want to use these XG Boost models on here. But fortunately, we have the temporal hierarchical forecasting, or THIEF for short, that did fairly decent. Okay. So what I want to do now is I want to capture the results, the things that I want to move forward with in my analysis, or the things that I need to kind of handle. And that is going to be dealing with the small time series. So that was the issue where we had right here, where all three of our models failed. I want to, and basically how I do this, I just take this error report, I grab this item ID here, and I store that as my ID small. So if there are more that have failed, I would store that here. And I need to just kind of see, here, actually, I think I forgot to run this one. Items, nested Modeltime Tibble, 102, filter item ID. Is that here? Okay, and then, so what I wanted to show you here is that this train split, we have this function of extract nested train split, and it'll extract the training data. And what I'm seeing here is that there's 0 and 90. So this time series is actually too small for this data set. That's why it failed. We can see that because I've got 0 for the training data. So we need to have at least some training data. So we're going to set this one aside, and we're going to handle that separately. So that's why I'm doing this right here. I'm going to subset that, that nested subset, and I'm going to move forward with my analysis without, so I have an exclamation point without that ID in here. So I only have 101 that I'm going to move forward with. So this is a key idea, is handle your errors and kind of separate those from the rest of the pack, and then keep moving with the rest of the pack, and then handle those errors later. So that's what we're going to do. The rest of this we can kind of speed through now. So now that we have the subset, which is just the 101 that are not failing, we can move forward with those. We're going to use the select best. And what that's going to do is select the best model. So for this particular one, it would select the temporal hierarchical model, which has the best RMSE. And you can use different metrics. I could use MAE. I could use any of the metrics that we saw here from our accuracy. MAE, MAPE, SMAPE, RMSE, and R squared. And you can add more. There's other functionality in Modeltime to do that. So we're going to use metric RMSE, Control Enter, and it's going to produce now, and we're going to store this as nested best. And then now what we can do is we can actually visualize and see which models that the time series or that select best selected. So we're just going to do this for the first 12 time series. And we can see for the first one, it's going to be this temporal hierarchical. So it's got this red. If I hover over it, temporal hierarchical. For the second one, it's XG boost. Third one, XG boost, XG boost, XG boost, temporal, and so on. So now we have selected the best models for each of these different time series. The next thing is refitting. So this will take 25 seconds. What we do is we then take, so now that we know which models we want to use, we're going to refit them on the full data set and then forecast them forward using the future data. It'll take a few seconds. If it doesn't wrap up here, I actually saved it in my artifacts and we can move forward with it. Always on the Zoom calls, it always takes longer to run through these things. So let's just give it a second. Okay, so let's see here. I'm seeing a few questions here while this is running. Is Profit built into any of these time series algorithms? We can use Profit actually. So if you go into the help documentation, Profit rig is from Modeltime. We have this profit regression, and it's just a model that we can use just like we could use for what we did up here with XG boost. How we have boost tree and we have temporal hierarchy. It's just another model, so we can add it in. All right, this is taking a little bit longer than I want to wait for. So let's do this. I'm going to stop this script, and it stops. And I'm just going to pull it in. I actually saved it already. So even though it's running in parallel, to retrain models on 100 different time series, it's a little expensive. So what I've done is I've refit, and now we have our model time tables that have been adjusted to be retrained on the full data set. So let's just check this out. We can also review any errors. Right now, there's no errors because remember, we set that one time series that was giving us some problems aside, and we'll handle that a little bit later. So now we can visualize the best best models. I'm using this extract nested future forecast to pull out the logged forecast that we had made previously and make that future forecast. So if we zoom in here, we can see that this is the future forecast now. It's using that temporal model, it's using the XG boost model, and so on, and it's picking the appropriate models that it should be using. Okay, so we have 101 of our forecasts done, but we had 102. So what about that small time series? Well, now what we can do, and this is what I would normally do in my process, is now I would handle that, all those edge cases that we had issues with. So the main reason that failed was because we only have 90 days worth of data. And in order to be able to split that up into training and test sets, if our test set are all 90 periods, because that's what you do. If you're making a 90-day forecast, you'd probably want to use 90 days in your assessment set. But for data that has less than 90 days, we can't do that. So we need to adjust the nested time series. So what I'm going to do is I'm going to just go into my sales, my raw data, which is what we started with up here when we did the nested time series. And I'm just going to rerun through this, but I'm going to make one small tweak. So I'm going to first filter my into my my small time series. This is the one that gave us problems. And we see we only have 90 data points. What I'll do is just like we did before, group by, extend time series, and then nest the time series and split it. But the main change that we're going to make is instead of length test 90, we're going to do length test 30. And this is going to use 30 days for an assessment set and leave the additional 60 days, the rest of this, for our training set. So now we're going to have a training and a test set. And this is how I would normally handle this for short time series. So now I have, and you can see 60, 30 here. So we've got 60 for training, 30 for testing. And then what I'm going to do is I'm just going to rerun this through the nested time series. Notice here that I tacked on nested select best. So I'm going to not only fit, I'm going to then select best, and then I'm going to refit. And this will give us the full analysis that we already went through. Okay, finished in about 7 seconds. We can see here, let's check it out. What I'm looking for now is model errors. There were no errors. And if I extract the future forecast, I can see what that looks like. And it looks something like this, where it's making the forecast now. And it picked the temporal hierarchical forecasting. So apparently XGBoost models weren't doing as good. The temporal hierarchical forecast is going to do the best. Now what I would do is I would then, now that I have some a model timetable that's working, I would just recombine that with the old results, this nested best refit. And now I have all of the results here. So nested best refit tibble. So I've got all of the results now. And now I can utilize these models for my forecasting. So what I'm doing here is I would save those best models. Those would be saved as my artifacts. And then one of the things too that you might be wondering is, okay, so I've got these models now. What if I want to change my forecast? So I've added a new function. This is bonus number 2. I have a new workflow function that I want to introduce you guys to. Model time nested forecast. So once you have these results saved here, your organization may say, okay, instead of a 90-day forecast, I actually wanted you to make a 365-day forecast. And you will then say, oh crap, I've got to rerun through my entire analysis. This is going to take 20 minutes or if you have 1,000 forecasts, even more. Well, now you don't have to do that. So you can just take the data the models that you have originally created, and you can pipe it into this model time nested forecast, H365. And, you can do the allow parallel. And what we're going to do is going to change, what's it saying here? Here, let me do parallel stop and parallel start. 6. Okay, and what this will do is give me 6 clusters that I can run this on. And I'll be able to make the forecast for all 100 of these. There it goes. All right, so it's beginning the parallel loop. And instead of taking, hours, it should just take a few seconds. And then once we have that data, we can then make our new forecast, which will be for 365 days. So let's run this. Yeah, it should finish here in just a few seconds. And when it does finish, we will be, I'm not sure why it's taking so long. It's definitely because my system's using a lot of resources right now. If you see, I'm maxed out. So I probably have too much stuff running, which is why it's taking, normally it takes like 7 seconds. Here, let me stop this. Yeah, let's do allow par false. Yeah, normally this will go a lot faster when you don't have all of that stuff running. So let's see. Okay, we got to go through each one of these forecasts, but this is actually a lot faster than having to make all of your forecasts through going back through this entire process. Okay, so while that's running, the key idea here is that we're able to change up our forecast, and that's really a good thing, to be able to change up the forecast for hundreds of forecasts without having to go through the full process of fitting models and unfitting. All right, so in the interest of time, I'm going to keep moving here. The last piece, the third bonus, is the Shiny app. So if you guys are interested, I do have Learning Labs Pro. All my OL Pro members are going to get this forecast app here. It's this document here. And basically you just click the run document. And what this is going to do is it's going to publish give you an app that's going to run on locally on your machine. It's taking a second because I'm of course maxed out here, but this is the app that would be produced. You can see we're at 51, 52 forecasts. And let's see, there it goes. So this is the app that the LL Pro members all get. All right. With that said, we'll keep moving on. So that's the demo that I wanted to show you guys today. There's a lot going on. There's a lot of technology that I've been working on the past couple of weeks, and I'm really excited for it. I think that Modeltime has a lot of capabilities now with both global forecasting and local or iterative or nested forecasting. So what do you want to do if you want to become the time series expert for your organization? Let's talk about how you might do that. So you're probably going to go through and kind of come through this mindset where I know when I was first starting out, it took me years to learn data science. I'm talking about just not even having boot camps were available, but there was so many resources, there's so much going on. And the challenge that I really found was that when I was trying to learn data science, and especially when I was jumping into time series, it was very challenging to learn. But the thing that really helped me was learning effectively. And if you want to become a data scientist, if you want to specialize in time series, you're seeing this code that I ran through today. There's a lot, going on to it. And it may not be familiar to you, but don't get discouraged because, this is an advanced analysis. This is something that is iterative in nature, and there's parallel processing involved and a lot of techniques. So, but there isn't a lot to get started. So that's the key point that I want to talk about now is how my career grew when I was learning data science. I started learning data science, and what I found was that the most important tools were data preparation and visualization. So the things that we were doing at the beginning of the analysis, that was really what most people in companies really needed, especially leadership, being able to develop analyses like these and be able to make data-driven decisions. The next most important piece was then the modeling phase, because this is how we begin, how you become able to predict what's going to happen and not necessarily just react to what is happening. So for example, if a customer is going to leave your company, how can you classify that person as a high risk category? Well, that's what you do with your machine learning and your modeling. And then the last piece, which is also, this is probably where your career is going to skyrocket the most, is when you start learning how to deploy apps and how to build applications that your company can utilize, and not just you showing or giving somebody a report one-to-one, but you can actually put an app out there that people can learn from. So just like this nested forecaster, the nested forecasting app, this thing right here, if we open it up, it's basically being able to build these where you have the forecasting apps. There it goes. And it's something that your business can actually use. You don't have to be overly technical. You just have to be able to pick the products that you want, be able to pick the forecast horizon and hit the apply button. And then what it does is it generates this forecast for you. And maybe you can download an Excel file or a CSV file. That is, when you start building these things, that's really how you help your business. So that's how your career grows. And that's why I've developed the program called the 5-course R-Track system that I'm going to talk about. So the first course in the 101 gets you started. That helps you get your foot in the door with data preparation and visualization. And by the end of that course, you're qualified to become a business analyst. Then you add in the machine learning, which is in the next 2 courses. There is an advanced machine learning and a time series course. And that's how you become a data scientist. You start learning these tools that allow you to go from descriptive to prescriptive. And then as you start learning Shiny apps and how to use cloud and do more automations, that's really where your career starts to skyrocket. At least it did mine. So the idea here is, with this 5-course R-Track system, you go through this progress where we all start at the beginning, where we don't really know a whole lot about data science. We might not even have ever used R, may have just been coming from Excel. And you know what? That's fine. That's where I came from. And that's a perfect starting point. But what the R track does is it condenses this into about 6 months, depending on how fast you can consume the courses. You can get through these courses pretty quickly. On average, it takes around 8 weeks, 20 weeks for these 2 courses and 12 weeks for these last 2 courses. And if you fly through these, you can become a senior data scientist within, say, 6 months or so. It's really, the tools aren't the biggest challenge. It's being able to tie yourself to the business and see how the tools integrate with your business. And that's what I teach you how to do. So the thing here, so if you're coming from time series, this is my friend Jonathan, and he is he's a finance guy. He's head of data and quantum research at Truist Securities. He's taken my time series course. This guy's, he's a seasoned veteran. And he says here that he's only 10% through, and he's already picked up a couple of super useful new moves. Well, that is pretty powerful statement, considering he's been using R for the better part of a decade and really knows his stuff. So if he's able to learn just a couple super useful new moves within the first 10% of just one of my courses, imagine what it's going to do for someone who hasn't never used R before or is in the very beginning stages. So this is where I can help you. Here's another example. Chris Seelig, he's a student in my university. He says, because of the R courses that Matt has provided, I landed my first data science role. So I'll go through in more details, but he says setting up Shiny dashboards in AWS was extremely helpful during my interview, as people interviewing me were looking for someone who had some knowledge of cloud technologies. So again, in your career, as you start to interview for these data science positions, you're going to need to have some background in cloud, and also it helps with deploying actual products like Shiny apps. That's going to help you. And he says, even though I haven't finished my Python course yet, that was also a huge boost, because although where I'm going is an R company, there are some Python people that I'm going to help support. So he checked off a lot of the boxes as he went through. So he's doing great things, and the courses are really helping. So again, back to this learning curve, this is where it really helps you to understand, hey, this is a path that can get me to where I need to be within 6 months. And now I'm showing you the proof that I can help you do it. So let me show you a little more proof. This is Jennifer. She landed a VP of Strategic Analytics role. She is now working for JP Chase, a big bank and financial institution, probably one of the biggest. And she says that she used my business science problem framework, which I teach in my 201 course. And she completed the interview project using R Markdown, which I also teach in my 101 course. The polished finished product impressed the hiring manager so much he was willing to fast track an offer. So she landed her dream job, a VP of Strategic Analytics role. But it's not just her, and it's not just Jonathan, and it's not just Chris. It's also a lot of my students. So these are all highly motivated students, and these results that they're getting showcases that. Masataki, he got a data science job. He's working with, I believe, BCG Gamma now, but he was with Deloitte. And he was able to land those jobs using a lot of the techniques that he's learned through the courses. Z is a data scientist at Amazon now, but when he first started working with me, he was able to kind of quickly gain enough knowledge to get a data science job and then also a senior data science role. Mohana, he got 3 raises in a year. A lot of that was attributed to my work. He was working with a lot of Python people, and he was able to run circles around them with R. Herb, he went from no experience to deploying his first Shiny app in 3 months. And I believe he's now become a senior data scientist. And then Raj, he actually won the 2020 Shiny competition, where he competed against, I think, 200 or so other individuals, and he was one of the top 3 winners. So a lot of things that you can do, but what is inside the courses that's helping these students so much? Well, it's more what you build. It's not what, the tools and everything that you learn is great, but it's the products and the projects that you complete. So this is one of 8 projects. This is an example here of the stock analyzer. This is in the Shiny Developer with AWS course. You learn how to put this onto AWS in the cloud. And what it does is it helps you or your company analyze different, all the S&P 500 stocks, which is good from a competitive analysis. You can keep track of different companies that are and how their stock performance, which correlates obviously to their financial performance. So you can keep track of that. We use the TidyQuant package. We have to use MongoDB, the Atlas software, or in the Atlas platform to be able to connect everything up, and then we host it on AWS. And it's all of these different technologies that you have to learn and integrate, and that is the thing that is the most valuable out of these courses, and that's why all of these students are having success. So, summary of what's inside my 5-course art track: thousands of videos, 130 plus hours of content, 8 end-to-end projects, a private community of mentorship where I am in there day in and day out, providing guidance and being able to help my students succeed, both through the courses and in their jobs, and applying analytics to their jobs. You get lifetime access. So once you complete your purchases, you get access to not only the courses as they are today, but all of the upgrades that I have planned in the future and the ones that I keep adding to the time series course and so on. And then I also offer a 30-day money back guarantee. So this is something that I've only ever had, I think 1%, less than 1% of my students ever request a refund. So that means there's a 99% satisfaction guarantee with this. But if for whatever reason you have any issues with the course, or you don't think it's a good fit, then I will happily refund your money. I don't want to have you in something that isn't working for you. So I do offer that. Just one of these apps in this end-to-end project, like for example, the stock analyzer, as a consulting gig, you can sell these for $3,000, $4,000. So I put a price tag, of a $5,000 value on this course, which is actually probably pretty low, considering all of the analysis and the 4 Shiny apps that you create throughout the courses. So you can see here, and I'm going to start a 30-minute timer. But what we're going to do is we're going to offer these courses today for $16.99. And that is a $19.99 for the 5-course system. And I'm going to give you 15% off today for the Learning Labs. So I'm going to post this here in the chat now, and I'm happy to answer any questions related to the courses. And if you have any questions, I'm also going to put the time series course in here as well, if you guys want to check that out. But the 5-course ARC track system, here, let's restart this. Got to restart my timer. There we go. So I'm happy to answer any questions. If you put it in the Q&A, I see there's quite a few in the Q&A. I'm going to pull that over now. And we can talk, about anything that you saw today, and including the art track, including any of the time series content, and so on. Okay, so the first question here: how relevant do you think XTS and Zoo will be given the whole Modeltime, Time Decay, and Tidy time series environment? So I think the main thing here to understand is that we are in a, software is constantly evolving. XTS, though, is very entrenched within the financial ecosystem. So that's actually why I built TidyQuant, was to be able to convert back and forth between data frames and XTS, because that was the problem that I was running to. Every time I tried to write some code that analyzed some stock data, it took forever because I had to write something to convert, a data frame to XTS. Then I had to do my financial calculation. Then I had to convert from XTS back to data frame. So that's two extra lines of code every time I want to do a financial calculation. So I built TidyQuant. I see people mainly moving towards the TidyQuant, but I do know that a lot of the financial people, they're dealing with XTS still. It'll be around forever. It's never going away. But I don't see as much development and as much new stuff coming out of that area as I do the Tidyverse and as I do data frames. Their data frames are getting faster. They're getting more. We're getting more power. We're integrating to all sorts of different the ecosystem is just exploding right now. So it's very exciting. So Eric, to answer your question, I really think, the future is going to be the Tidy Time series, but I think the XTS and the history and I don't think it's ever going away, but XTS I think will be around for a long time. I don't know that'll be as advanced as much as some of the Tidy Time series tools though. Anonymous asked, do you have any forecast suggestions for novelty products? So special ML models. So there's different machine learning models that you can use depending on what type of we'll say like what profile of data you have. If it's an intermittent time series, we saw XGBoost works pretty well. This Thief works pretty well. We also have some other stuff. Alberto, if he's still on, or I see him. He's actually working on some cool stuff for me for Modeltime, where we're going to be including this package called Smooth, which has a lot of time series forecasting algorithms that look pretty promising. It has an exponential smoothing that allows us to use XRigs. So if you use the forecast package, exponential smoothing, you can't use XRigs or external regressors. So we've got that coming. We've got it's got even another algorithm called Atom that looks very promising. There was a nice paper that the guy who built Smooth, he wrote in I think January or February of this year. Very cutting edge, looks really promising. So there's going to be a lot more coming to Modeltime, especially for kind of these certain special situations. Things like Thief, the best thing you can do is don't fall in love with one algorithm, but try out a bunch and see what works. We see that with the time series competitions all the time. The winners are testing a lot of different things out, and then they're running with whatever seems to get the best results. And then they're implementing techniques like ensembling, which we have Modeltime Ensemble. I teach that in the course. And we're also using things like global forecasting to reach scale. We saw, even with the iterative and parallel, it still takes a long time and consumes a lot of resources, which we saw that in this training. So there's a lot of stuff coming. Very, very excited about it. And I think that you just want to test a lot of things out and see what works. Okay, the next one. What is the best for short life cycle products? Such as if we have products which we only have 12 months of data, but the business wants to forecast results for 28 weeks. So 28 weeks, what is that for? So yeah, we've got 28 by 4, and we'll pull up. So 28 by 4, oh, whoops, not 58, 28 by 4. So you're trying to forecast a little over 6 months. So the challenge with that, when you only have 12 months worth of data, that still can be done, but you're not going to get any yearly seasonality. Normally you need 2 periods to get like the yearly seasonality. So you want to have 20, probably at least 24 months worth of data if you want yearly seasonality. So that's going to be the issue. It still can be done. 6 months, you can forecast off of 12 months, and just might not be as accurate if you had two full cycles worth of data. So that's what I would say. We saw in this training, I made a 90-day forecast off of 90 days worth of data. It can be done. Is it going to be that good? Who knows? It's probably not going to be as good as if you had more data, but it can be done. And you just have to get through these certain situations. Sebastian asks, where can I find this script? So everything that we covered here today is actually in Learning Labs Pro. I'll put the link in one more time. So Learning Lab Pro is kind of these are where all of my webinars get stored. And I store it with all of the code, the slides, the video. So the video that you're watching right now, this will all be recorded and stored in Learning Labs Pro. And the advantage is it's probably a little bit more advanced on the advanced end, but it's, I designed it for people who have completed my 101 course, either in Python or R, that usually qualifies them to be able to take Learning Labs Pro. And I really designed it for my students. Basically, they were asking a bunch of questions where they wanted to to know, where they could learn more even beyond the courses. So I made Learning Labs Pro. We've been doing it for about 2 years. Every couple of weeks, I'll do a new a Learning Lab. And it's really just to showcase what's new, what's upcoming, what's advancing in both the R and now the Python ecosystem. So check that out if you want to learn more and get the R script, any of the R script that you found today. Anonymous attendee. What if your data is imbalanced? Meaning here the data all have the same number of data points, but in reality, we can get into some products that start on different periods and it's not always going to have the same number of points. What should we do? Well, we saw a situation today actually where one of the data points was imbalanced, meaning it only had 90 days, whereas everything else had, 5 years worth of data. So really, what you're asking is basically the same thing that we saw here today. Now, you need to kind of take a look at each of these time series because sometimes, even though it's imbalanced, maybe you can get away with padding. And what padding is called is, I teach this in my time series course, but it's where you add zeros to fill in the gaps, or you add in a value to fill in the gaps where you might have some missing data. Now, that would not have helped us in this situation because it would have just told us to predict 0 going forward. Whereas, in reality, it should be closer to 1, per day, 1 unit being sold per day versus 0 units being sold per day. So what we did in this situation was we partitioned out, or we set aside the data that was not falling into the right pattern. And what that allowed us to do was then to treat that separately, where we could make a forecast where we broke our 90 days of data that we did have up to 60 and 30. So 60 days for training, 30 days for testing. And then we made a 90-day forecast off of that. And we saw, when we had some confidence going into that. So that's what I would suggest is treat data imbalance just as you would as, any type of error. So if you run into an error with it, or if you want to treat those separately, partition those data, those time series out and handle them separately. And that's what we did here. So good question. That was a good one. Rahul asks, is there any support for Spark in Modeltime? Not yet. We have it on the roadmap though. What if data sets are too large to fit into RAM? So this is a great question. So Spark and Dask are the two kind of platforms that we're looking at right now for big data or out of RAM. And what we want to do is figure out a way to get Modeltime to be able to do utilize some of those technologies to be able to avoid the issue of when our data sets are too large. Now, for most people, this isn't as big of an issue, but for time series, when we get into these super large data sets, like for Walmart, where they have millions of products, that you certainly can't fit in the RAM because it would just be way too large. You'd have to have a supercomputer. Supercomputer is not out of the question because computing is getting cheaper, but you may want to use Spark. So we've got it on our roadmap. I don't have a time frame on it yet, but it's definitely something that we're going to look into in the future. Okay. Trevor asks, how is the nested approach different than the ensemble time series modeling discussed in DS4B 203 course in section 14? Conceptually, they are very similar. Would you recommend one approach over another? So the ensembling approach in section 14 that Trevor's referring to is where we use model time ensemble and we take 5 or so different models and we kind of average them, or we create a stacking, like a super learner is what it's called. So we go through a few different approaches there. The technique that we're learning here, so while we are doing that in the course, what this is doing is it's iterating kind of the same type of approach where we're just analyzing one time series, but we're doing it iteratively. So the difference here is now we're iterating and doing many models for many different time series, whereas in section 14, we just did many models for one time series, and then we came up with an ensemble. In section 15, though, of the course, we did global modeling. Global modeling is a different approach, and it's much more scalable, meaning it runs a lot faster than what we did here. So our iterative approach, where it took 2, 3, 4, 5 minutes to churn through 100 different time series, the global modeling approach will go much faster because you're just making one model, one global model for all of your different time series. So it can scale much better, especially with technologies like XGBoost or Light GBM or Cat Boost. So I would say pros and cons. The course teaches you solid foundations. So like ensembling, that's a competition winning strategy. So I think one of the Kaggle competitions, all of the recent Kaggle competitions, they've all won by ensembling, combining multiple models. So we're teaching that concept in there. What we taught here though is a new technique, which is for iterative. So this is for kind of scaling out in an iterative approach. So I would say that the pros and cons, what you learn in a course are faster, more scalable, may not be quite as accurate, but have certainly done good enough to win time series competitions. The approach that I'm showing you here is an iterative approach, which is also very good. It tends to be more accurate, but slower. And that's what you need to balance. The parallel processing side of it can help speed up, especially if you have many cores on your machine. But it'll almost always be slower than the global modeling approach. So, course for the global modeling approach is very good. I even use that when I'm doing the forecasting for my own business. Mark asks, how do you store nested artifacts? Most read-write methods in R are very slow for nested structures. RDS, ironically, we developed an internal library that does nested forecasts in batches of 1.5 million time series, and actually ended up changing some of our nested data structures because it was so slow to write artifacts. Maybe we missed something along the way. So when speed becomes an issue, and let me rewind. So what Mark is asking here is a really good question. He's basically seeing an issue where he's got 1.5 million time series, which is a lot of time series. I mean, we're talking anything over 1,000, 2,000, 5,000 time series, and that's when we need to start thinking, in my mind, of trying different solutions like the global modeling approach. I think that would probably be a better solution than the nested approach. So I think that solution-wise, nested will be most accurate, but like you're seeing here, 1.5 million time series, it's going to be very, very large. Certainly anything more than probably 10,000 time series, and you're going to be asking for issues with a normal computer. That's where you want to go to the global modeling. Now you're talking orders of magnitude more than that. So 1.5 million versus 10,000. So I would cut off, much sooner than that, and I would switch to a global model. That's what I would do. Whether or not your business is accepting of that, that's something that you'll certainly need to think about. But storing the nested artifacts, it'll get really, really large. I mean, we're talking these nested artifacts for 100 time series are 180 megabytes, very large and that's just 100 time series models. If we talk about 100 times that, I mean, you're talking gigs and terabytes, and eventually it won't fit into memory. Okay. We're going to keep going here. We got a few more questions to answer. Luis asks, does your package require that dates be continuous? What if there are 0 sales on a particular day and it's a valid value? It doesn't require that for sure. Some time series, you kind of got to decide whether or not you should pad them or not, depending on the algorithm. Algorithms like XGBoost, doesn't matter. I mean, you could jumble up all of your dates and still forecast, different timestamps, because those features are, the date pattern doesn't even matter. It's mainly that date is a feature because it has a certain day of the week that it falls on, a certain month of the year, and so on. So if you have 0 sales, it may or may not affect Typically data like ARIMA will get more affected because those are the ones that you need to decide whether or not to keep that zero in there or get rid of it. Because those are structurally, you have to have, it's going to look at so many lags. And when you start adding in lags, then you need to have that time series structure. And if you're missing days, or if you're, if it's not consistent, Monday through Sunday, or, if you're missing certain days, then that could be an issue. You have to decide though, and kind of go through and experiment. So I would recommend experimenting and seeing if it works, or if it doesn't work, if it gives you good results in terms of, all that matters is the forecast on the test data set. If your test data set forecast is working out pretty well, then you don't need to add in those days. If it's not working out too well, then maybe you need to try experimenting and figure out if there's a better way. So that's what I would say, Luis. It's a good question. I would say experiment with different algorithms. Not all algorithms, XGBoost, I can tell you right now, is probably not going to matter that much, but ARIMA, it may, and you just got to see what, how well it does. Okay, Flavio asks, Matt, looks like extract nested train split is not on Modeltime's CRAN version. Oh, I forgot to mention that at the beginning. I will put that in the notes on the Learning Lab. So yes, this is all dependent on the development version of Modeltime. So we have to use the GitHub version. So you're going to want to install that. I'll put some notes in the Learning Lab to make sure that none of the students, when they try out the code, they get that. I haven't released these changes. It's so cutting edge. I haven't had time to release them to CRAN yet, but I would expect probably in the next week or so, I'll get these updates onto CRAN. Okay, what does extend series do? So Anonymous asks extend series. So the extend time series function, what we're doing is we're taking the dates and we're going to be basically extending them into the future. So if you think of your time series where you've got a date and a value for a particular item, that dates goes, maybe Monday, Tuesday, Wednesday, Thursday, Friday, and then eventually it ends. But we want to forecast the next, 90 days. So we need to extend that into the future with a missing value. So all that does is it just extends each one of those time series. So for each of the different products, 90 days into the future, because we set it up to extend it for 90. So that was a good question. Rajiv asks, hi, Matt, how do you factor in external regressors into the models such as TV, GRPs? Also, can Modeltime handle weekly data forecast? It can handle both. So if you have external regressors, you can do that in the nested time series structure. So the key is that you're going to want to add in, when you make your future data, you're going to want to make sure that you have in some future values that you can use as XREGs. And if you have those, then maybe you've already forecasted GRPs and you want to include that in your model. You can add those in. So it's basically in this step here. Let's see. In this step right here where we did the nested time series, after you extend right here, you would add in your external regressors before you do your nesting. And then once you add your XREGs in, like TV GRPs, or, if you've got weather data or some other data that you want to do, you just join it in here after you've extended. Okay. Good question. So Mark asks, I have to drop. Awesome work. Thanks for sharing. Would love to answer to my question via email. Okay. Well, I think I just answered it. And we'll try and see if we can get that answered via email as well. Anonymous, if I buy the Python course or time series course, is LL Pro free, or is it a different subscription? Good question. It's actually a different subscription. It is something that many of the students are doing both. But because we're constantly releasing new content, we've set it up as a subscription model because you're always getting new content every 2 weeks. We're sending a new 1-hour lab to you. That is, something that you need to subscribe to because the content is constantly growing. Versus, the courses where it's just a one-off. Now you still get the any changes that we make, you still get those, but it's generally just a flat fee. So good question. It is a different subscription, but you're welcome to join both. Start out with the courses, maybe add LL Pro once you get through the 101. That's usually a good strategy. And that's what I normally recommend. Luis asks, to clarify, if there are 0 sales and no record for that day, is that a problem for Modeltime? No, not necessarily. It just depends on how you model it. If you get good results. So for example, if you have a missing day for XGBoost, XGBoost isn't going to care because it's just not going to see a value for that day. If it was truly 0, meaning you had 0 sales, you may want to put 0 in there, but you might not, and it might not matter. The only thing that matters is when you split up your training and testing data set, how well you do on your test, because that's really what's going to confirm to you whether or not your strategies are working. If you're getting bad results, meaning your errors are really high and you visualize your forecast and it just doesn't look good, then you need to do more work and you need to start to figure out, try these different things like padding your time series, like maybe imputing your time series, and you need to get a little bit more, well, what I'll say is, start trying to do, some different things, maybe add rolling features in to help, smooth out your forecasting. There's all sorts of different techniques. I teach feature engineering. I teach, I think 6 weeks of it in the time series course. Or 6 modules of it in the time series course. I go into a lot of depth on how to do feature engineering, and I think this would fall under that. So definitely check out the time series course if you really want to get in deep into feature engineering. Mohammed asks, hey, Matt, what is the difference between panel models forecast and then nested forecasting? So panel models is the global modeling. That's where you have one model for all of your time series. So if you have 100 time series, you'd still only have one model that predicts for all 100 of those time series. That's what we call modeling panel data. But in the nested forecasting, what we're doing is different. We're forecasting for 100 time series, and we need 100 different models, one XGBoost model for each of the models. Actually, we made 2 different XGBoost models. So we had a total of 300 different models because we had 2 XGBoosts and a temporal. If we were doing it with global modeling, we couldn't use the hierarchical or the temporal hierarchy. We couldn't use Thief because that doesn't work for global, but we could use the XGBoost models, and we would just make 2 XGBoost global models. And we would just have 2 models that predict all of the time series, and we'd pick which one works best for each of the individual time series, but it would be 2 global models. So that is kind of the difference. When you do panel modeling, you're making 1 model versus when you do nested modeling, you're making hundreds of models. Okay, Anonymous asks, is there a flat 29-month pricing to access the labs and the courses, or is it a separate price? It is a separate price for the courses. And again, the courses, there's just so much value in it. There's literally over 1,000 videos in all 5 of the courses when you combine it. So there is just so much content, and that is why that's why the price is $16.99. For the learning labs, there's still a lot of value to it, but those are more webinars that I'm just doing every couple of weeks and giving the bonuses away. So that has a lower price tier, and it's still very valuable, but it's separate. So when you buy the courses, you need to, if you want learning labs, you'd have to purchase that separately. Anonymous asks, for someone who has some experience with R, would it be better to go for the labs or the courses? Ooh, that's a good question. So if you have some experience with R, you may want to pick out certain courses. You can buy them individually. So for example, Shiny, if you're looking at upping your game in Shiny, I highly recommend the Shiny courses. These 2 courses here will teach you so much about Shiny. It goes into so much depth. And it's not even just Shiny, but it's how to deploy Shiny, how to use AWS, how to use Docker and Git, how to do version control, how to control your environment, how to do software engineering, like all these different tools and techniques you're learning, and you're learning HTML, CSS, like really how to control your apps. That is, to me, what I would do is I would pick out which courses you'd like. And then also LL Pro is a no-brainer. Get that content every couple of weeks. You're getting a new Shiny app. You can then take the courses and then see the new app. And then you can start to dissect the app and see, oh, hey, Matt taught this in the course. This is how he's, and this is a different app. I see how this works. So I get those comments a lot from the students where they're taking the courses and then they see the apps that I offer in the labs. So can I get only the advanced ML and time series web apps and Shiny? How much are for those 2 courses? Well, I think those are 4 different courses there. So advanced ML is one course right here. Time series is another course. And then the web apps and the Shiny developer. So this is actually 4 of the 5 courses. So if you don't want the 101 course, what I would do is I would recommend picking up different courses individually. Now we package the whole system together this way. And it's basically like, getting essentially a free course plus a discount. So you're getting lots of course. Trust me, this is a lot of course for this price. Okay. Jeff asks, does the time series course include the new additions to the model time? Good question. I am going to add this to the model time course as well. So if you purchase the time series course, you're going to get this video as well. I made that decision yesterday. I got several questions from my students, and since they're in the time series course and I felt that this would be valuable to them, I'm going to add it to the time series course for sure. It's going to go in the 4th section in the time series course under special bonus content. And then you'll have this video on the nested model time. Okay, Evgeny asks, hi, Matt. I do not see Learning Lab 63 and Learning Labs Pro. Sorry if I missed something. Well, that's because I'm recording it right now. So yes, we need to, we're going to add this to LL Pro. How much is the Python track? Well, we only have the first course created. So that first course is $4.99. I'll put that in. If anybody who's interested in Python, I'll put that in and we can give you 15% off today. The Python courses, I just put that in the links. If you're interested, it's a $399 course, but then you'll get a 15% off coupon there added. Jeff asks, I lead a small team of data analysts and data scientists. Primary system environment is AWS. I'm looking for a course to help level up the data analysts from Tableau and Adobe-based reporting to R Markdown and Shiny. Do you offer corporate packages to the R-Track system, or do you only do individual purchases? Also, as a sponsor, how would I be able to track progress of the team? So those are good questions, Jeff. We do have corporate packages for teams. So we can do special seat-based plans for your team. And what I would recommend is reach out to me via email or through LinkedIn. And we can handle those on a case-by-case basis, or if you go to the contact form. I'll put the contact form into the chat if you're still on. So business science. What I would do is I would reach out to me through the contact form, contact, and I will put that right in here for you. So just reach out to me through the contact form and we can see what size team you have and create a team plan for you. Okay, Anonymous asks, when do you think the next Python course will be offered after the automation one? So the next Python course, we're going to try and shoot for November, but realistically, it may be closer to the beginning of next year. The reason being, I have several things that I'm working on and we're having to juggle a few assignments right now. But it's going to be coming. It's going to be soon. We're really excited for it. It's going to be more in depth into machine learning in Python, and which is one of the biggest strengths of Python. And we also are probably going to be adding in some new things like Fast API, which is for developing machine learning APIs. So we're testing out a few things, and we want to see what we can all offer in this. But it's going to be exciting, and we're really pumped about it. Mohit asks, can we get a discount coupon for the Python course as well? I just put that into the link. So if you want to check out the Python course that I just launched here back in June, check that out, 15% off. It's in the chat right now. Leo asks, what do you do to prevent selecting an overfitting model as best with a large number of time series? So, overfitting is a challenge. We can get, especially with like these high performance models like XGBoost, you saw how like there were some extreme dips. So that select best does actually a pretty decent job at hopefully minimizing the overfitting with the iterative process. For the global models, there's two different things I do. Number one, I'll select individual models that do the best on time series, but then what I'll do is I'll use the model time ensemble package to average them, using either a mean or a median, or sometimes a weighted average, depending on what the ranking is of each of the models, whether it was the best or second best, third best. Those are the strategies that I normally implement, and that generally gives me a better forecast when I do. And it most certainly fights overfitting, which is a big issue when you have like XGBoost in there, which just kind of, latches on to every little tidbit of your information. So don't get me wrong, really great algorithm. I love it. But it can overfit. It can overfit badly. So that's why I would say, Leo, check out the model time ensemble package. Luis asks, if there are 0 sales for an item and there's no record for that day, is that a problem for model time? Oh, that's a duplicate. I believe I answered that. It shouldn't be a problem, but again, experiment. Neil asks, is this learning lab currently live on the 203 page? No, not yet. We need to go through and add it. It usually takes me 24 hours, so I will add it here right directly. Kadir asks, I received an email from Teachable about my subscription canceled to LL Pro from August. I was trying to add my new card. Okay, Kadir, what I would do is reach out to me through the contact form. I'll give you the link and we'll figure out what's going on. Contact Business Science. And what I would do is I'd just reach out to me. Okay. Luis says, thank you. We're good. Sorry for the duplication. Nope, no problem, Luis. No problem. Okay. Evgeny asks, another question. Do you plan to implement Bayesian approaches? Yes. Actually, Alberto, I don't know if Alberto is still on the call or not, but he has Bayes models, which is the time series. So if I do Bayes models, model time, and we'll probably do another learning lab on this, but there is a model time integration of Bayesian version. It's called Bayes models. I'll put the link in the chat. There, Alberto is here. So this is the link in the chat. Yes, I would check out this package, and we'll probably do a learning lab on some of the model time extensions, and check out this one certainly. Okay. All right. Let's see. One last question here. Alexander, hi, Matt. Why are there no lag or spline variables in the model recipe? So you can implement lags and splines in the recipes. So if you go to time TK, so I teach this in the time series course, time TK package. If you check out, there is in the function reference APIs. So there's all sorts of different what are called feature engineering recipes. So pre-processing and feature engineering here. You can do different steps. Lags, I normally implement those outside of recipes. I don't put those in recipes normally. I normally add them in as separate features early on before we get to recipes. But splines and things like that, you can add in as well. So each of these are different time series pre-processing steps, like box Cox. You can do step smooth, which puts a low S smoother, step slidify, which does a rolling window transformation. Fourier series in there, all sorts of different ones. There's also a step lag. I don't recommend doing lags in the pre-processing recipes, because you have to have a way to get those lags into the future data. And if you do it in the pre-processing recipes, it won't work. Okay. Tony asks, hi, Matt, is there a website we can see all the current model time packages? Yeah, so if you go to model time, and this is the website for model time, it's right here. I'll put the link in the chat. So if you go to the ecosystem tab, you can see all of the different, these are the main packages. Now there's a bunch of other ones like Alberto and several others are developing. So like Bayes models isn't featured in here, and we have to figure out a way to kind of point people to that. But these are the main ones, like for example, Modeltime H2O. This is the H2O AutoML solution. It's something that there's, that's how I would go. And then you can get back to the Modeltime package here and so on. Eunice asks, is there a Python counterpart to today's tutorial? I am planning to deploy models using Fast API. So I wonder if I can do a Python pipeline. So there's no Modeltime equivalent in the Python ecosystem. The best that I'm aware of is SK-Time. But if you look at it, it's very, it's kind of one time series at a time. So if you go to SK-Time here, and I teach a little bit of SK-Time in my 101 Python course for doing like ARIMA and ETS. But, you have to look at their roadmap. They don't have a lot of stuff implemented yet. So if you look at kind of what's on the roadmap, multivariate data, new algorithms, parallelization. I want to see if they have panel forecasting, which is not yet implemented yet. I don't even think they have the iterative. I'm not sure if you can do the iterative piece yet, if they do that. So really, I think they focused kind of their efforts on some of the algorithms, which is a good place to start, but they don't have anything for scale quite yet. So I don't think that there's necessarily, you'd have to write your own loops and stuff. So yeah, I would check out SK-Time for Python. Maybe I'll try that next week or in 2 weeks to see if I can do something with it. But generally it's going to be a lot more code. So it might be several, instead of, we saw 200 lines here to do everything, you're probably talking 1,000, 2,000 lines. So I don't know that we'd be able to cover all of that in a learning lab, but I can try. So I'll take a look at it. Okay. Any other questions? Last couple seconds here. Did the timer? Oh, it looks like the timer's up. Here's your last opportunity, $16.99 for the 5-course R-Track system. Let me know if you guys have any questions. We do have just another second here. If you guys have any last questions, I'm going to put the link in here. Okay, we do see one that just came in here. Would you recommend predicting multiple time series greater than 100 using R than Python? I think you can do it in either. There's no reason that you can't do it in R, and there's no reason you can't do it in Python. But I think the main challenge is how many lines of code do you want to write, and everything's already kind of taken care of for you with Modeltime, because I spent 3 weeks developing all the software to do everything in parallel and kind of take it from the ground up. I'm going to put a few more links here in the chat. If you guys have any questions, I have Learning Labs Pro, I have the time series course, and then I had a few questions on the Python course as well. So I'm going to put those in the links in here. And if you guys have any other questions, reach out to me. You can contact me through the website, or definitely join the courses and you can get my mentorship. So, all right, I will catch you later, and thanks for tuning in. Have an awesome day, and hopefully I'll see a few in the courses.